In this video, we're going to go over some examples from the material in section 10.2. This first set, we're going to write an equivalent expression using radical notation, and then, if possible, simplify. So just some practice going back and forth between rational exponents and radical notation. So remember that this numerator is going to be the exponent, the base is the radicand, and the denominator is the index. So we'll have our radicand of m, our index of 3. We do not need to write the 1 because 1 is understood. So that's our answer, the cube root of m. In this one, we're going to take 9x to the 8th, that's our radicand, and our index is 2, which means we don't have to write it. And the exponent, of course, would be 1, which we don't have to write. So now we're looking at the square root of 9x to the 8th. The square root of 9, its principal square root is 3. And the square root of x to the 8th is x to the 4th. X to the 4th times x to the 4th equals x to the 8th by the product rule of exponents. If we look here, we have an even exponent on the x, which means that even if x were negative, we would end up with a positive number when we took it to the 4th power, so we do not need to put absolute value bars on that answer. And this last one, the radicand again is the base, so we're going to take xy squared z. The index is 5, and since we have a 1 there, we do not need to write that exponent. And then if we look in our radicand, there's nothing that has a 5th root that we can pull out. So we're done. Here we're going to write an equivalent expression now using exponential notation. So now we're going to go from the radical notation and now use rational exponents to say the same thing. So again, our radicand becomes our base. Our index becomes our denominator. And if there's no other numerator, if there's no other power there, we have a numerator of 1. So this is 4x to the 1/3. In other words, 1/3 power is the same as the 3rd root. And here again, the radicand becomes the base. The index becomes the denominator. And we have an understood 1 for the numerator. In other words, taking something to the 1/5 power is the same thing as taking its 5th root. Now we want to use radical notation to write equivalent expression and then simplify. Okay? So what does this tell us? 8 is our base and that becomes our radicand. 3 is our root because our index because that's the denominator. And 2 is the exponent. So we're looking for the 3rd root of 64, which happens to be 4. Here we have 9 is our base that becomes our radicand. 3 is the exponent, and 2 is the index. We don't write it. Now 9 cubed is the same thing as 3 to the 2, 3 squared to the 3rd power. Right? Because 9 is 3 to the 2nd power. So now we have the square root of 3 to the 6th power. 2 times 3 is 6. And that is the square root, and I'll write this out because it's gotten a little bit complicated here. 3 cubed times 3 cubed. And the square root of 3 cubed times 3 cubed is 3 cubed, which is the same as 27. We want to write an equivalent expression using exponential notation. So again here, remember that the radicand becomes the base, the exponent becomes the numerator, and the index becomes the denominator. Same thing here, we have 3xy is our base, and I'm just doing the inside of the parentheses now, just the part in here. And that's going to be taken to the 1/5 power. There's no other exponent on it, so 5 being the index becomes our denominator. But then that whole thing is taken to the 2nd power. So we'll end up with 3xy to the 2/5 power. Here we're asked to write an equivalent expression with positive exponents and, if possible, simplify. So we're not asked to bring anything back into radical notation. We're staying in exponential notation. We're just trying to clear out our negative exponents. So this 8 to the negative 2/3, the negative tells us bring it down to the bottom and give it a positive exponent. When we bring it down to the bottom, we have to put that numerator of 1. Well, 8 to the 2/3 power means we're going to square 8 and then take the cube root of that. 8 squared is 64 and its cube root is 4, so we end up with 1/4. In the second example, this 9 to the negative 3/2 needs to go down with a positive exponent, and the x to the 1/5 is going to stay up because it has a positive exponent. And 9 to the 3/2, we can either do 9 cubed and take its square root, or what's going to actually be easier is to take the square root of 9 and get 3 and then cube it and get 27. So we'll end up with x to the 1/5 over 27. Okay, this one's a little bit complicated. We're asked to simplify, and we're going to use the laws of exponents. Now, it's only looking more complicated because it has the fractional exponents, those rational exponents, okay? But we're going to take it step by step. And the power rule tells us that we're going to take each of these separate parts, to this power. So we'll do x to the 1/2 times 3/4. When we take a power to a power, we multiply the exponents. And y to the -1/3 times 3/4. X to the 1/2 times 3/4 is x to the 3/8. And here, I'm going to do another color of yellow. Our 3's are going to cross out. And we're going to get y to the -1/4, which comes down as y to the 1/4. This is the last example we're going to do. It says to use rational exponents to simplify. Do not use exponents that are fractions in the final answer. So if we get a final answer that has fractional exponents, we will need to change it back to radical notation. Okay? So here, our radicand becomes our base, x, y squared, z. Doing within the parentheses first. And that's going to be to the 1/3 power. The index becomes the denominator. Since there is no other exponent here, we'll use 1 as the numerator. And that is going to be taken to the 9th power. Now we have power to a power. We multiply our exponents. And we have x, y squared, z to the 3rd power. 9 times 1/3 is 9 divided by 3 is 3. And again, we have product to a power. We're going to take each of these to that power. X cubed, y to the 2 times 3, or y to the 6, and z cubed. And that is our final answer.